All right. Welcome to this new session class, Master of Science students. Um, During the past, I think 2 weeks, we've been looking at conformation analysis, and I think uh, you've really enjoyed that one by looking at the videos and the lecture notes. And also, I think we're able to describe the various conformation using uh, molecular models. Yeah. So I think uh, at this time we want to move to a new I can call it either a topic or a chapter, and that is on thermodynamics and also kinetics. For a start, I'll just discuss thermodynamics, and then we'll focus mostly on the kinetics. There's a lot about kinetics. Um, so thermodynamics, you're talking about reactions that are governed by thermal stability. You're talking about you leave a reaction and then it equilibrates, and then the most stable product, the most stable intermediate will be the one which will be formed in large quantities. In that case, so in this case, it will be these are thermodynamics, as opposed to the kinetics. We'll be talking about kinetics, how fast a reaction takes place. It may not form the most stable product, but we'll be talking about study of how quickly a reaction takes place. Yeah, and that one is quite important because you can say a product may be stable. Yeah, uh, but how long does it take to form that product? Yeah, especially from an economic point of view. You not want to wait a week or 2 weeks or even a month or even a year to form a product. Yes, you're going to form the most stable product. At what cost to the economics, for example? Yeah. So kinetics matters because it is a science that governs on hey, these are the conditions that need to be right for this reaction to move quickly, and it works together with uh, thermodynamics in a way. So in this case, you can say in this topic is about kinetics and thermodynamics. But I think before we look at kinetics, let's focus on the thermodynamics. Okay. So and once again, this course, uh, you're going to be taught more about some of these things which I'll be mentioning here uh, uh, by your lecturer who will be taking you physical chemistry. So I'll just be mentioning on the surface, just not touching the mathematical derivations and everything and so many things, but just uh, mentioning that which will be relevant uh, to you to be able to understand this course, because you might find that as it's been happening in the previous years that we've been looking at a study of free energy and entropy uh, at a time, what do you call it, far ahead of uh, tackling the same course, tackling the same topics under the physical chemistry. So this one will just be mentioning this uh, some of these terminologies, but the actual derivations you're going to get them in the physical chemistry. So in a chemical reaction, in this case, uh, I'm just giving some of the things that you are well familiar with, that there are bonds that are going to be formed, and there are bonds which are going to be broken. So I think you know that if you're going to form bonds, if you're going to be forming a more stable bond than the one which you're going to be breaking, then there will be heat given off in the to the environment. And once again, I would like to not uh, mention those terminologies. The E being Q plus W, the work, and then the heat to the surroundings and everything. But all those things you are going to learn in the physical chemistry. So in this case, there is a terminology there, and I think this ones I'm going to give in the next slide here. Uh, this is one of the, okay, there is H, there is G, there is T, and then the S. These are called state functions. But once again, I may just mention what are state functions without overlapping with what you may be taught in the physical chemistry. So these are things which I'm going to be talking about later. So there is the absolute state function. In this case, the enthalpy. But what will be of interest to us as organic chemists will not be the absolute enthalpy, but the change. So that in this case, we'll be talking about the change in the enthalpy, whereby it will be given by the equation of the final enthalpy. You subtract the initial enthalpy. Yeah? So in this case, what you're going to find out is that if the final one will be less than the initial, it means that the product is more stable. But if the final one is uh, is is more than the initial, it means that the product is actually absorbing energy. So you're going to come to those uh, uh, okay, we're going to mention a few things about those ones, but I think these are familiar terms. I hope you can see. I'm just trying to see whether the focus is corrected, that you can be able to see, and probably zoom correctly to see the screen from there. Yeah. So there are two familiar terms. Delta H being negative, it means that you are seeing there is an energy of a system, or maybe of a reaction, and in this case there is a negative sign before that. Then you know that in this case it's like an exothermic reaction. Heat is given off into the system. But delta H can also be positive. In this case, you're going to use the word endothermic. Therm being heat, exo being given off, endo being absorbed. Uh, Once again, uh, this equation can be derived from the first and second law of thermodynamics, but I think I would rather leave it at that. Uh, the uh, the term called the free energy, or the ability to do work, is equals to the change in the enthalpy minus the absolute temperature in Kelvin. So that in this case, it will mean that if you are given a problem, and then your temperature which is given is in Fahrenheit or is in Celsius, you've got to convert to the absolute temperature in Kelvin. Yeah. Yeah. Uh, so in this case, I want to introduce some two terminologies which I think, or maybe you may have heard about it. Let me say you may not. In some situations, you may have heard about it. Uh, there is delta G being positive. It means it's called endergonic. Yeah, endergonic, or delta G being negative, being hexagonic. It means that uh, do I bring it now? Yes, I think it means that a reaction is likely to be spontaneous. That's what it means. If you're going to have delta G being negative, it means that there is the ability to do work, that there is free energy. I'm saying things because this thing is leading to something of a plot between the free energy and the progress of a reaction, something which you're going to be calling the reaction coordinate diagram. And therefore, to have that one, you need to know why we are saying, hey, some that that the most stable are going to be lower and the unstable, like the transition state, are going to be higher on top. It means that there is positive delta G. The ones which are going to be negative are going to be stable, something like that. So the more negative, the more the ability to do up. So there will be a plot later. We look at that one, or something called a reaction coordinate diagram, whereby there will be what? There will be a plot of the ability to do work, which is going to be called the free energy versus the progress of the reaction. It means that in this case you've got your your reactants, and then they proceed through whatever, but that one I'm going to explain later, and then eventually it's going to lead to a product. So you are going to see something called a reaction coordinate diagram. Okay, so there's the delta G being negative is the one which we really want to really focus on if you want to show that, hey, this reaction is spontaneous. No, I think more about this. I think I'm going to explain in the next one, but you're going to see that for you to get a negative figure, then you're going to have delta H being negative, and you want to avoid this term which I'm going to be calling entropy being negative. But once again, you learn about what is this thing you're going to call entropy, or the degree of disorder. So I think I think after a short while, I think I just gave different scenarios as to uh, under what circumstances you can get uh, the free energy, the change in the free energy being positive, being negative. In this case, you can say the reaction is spontaneous, and if it is positive, then the reaction is not spontaneous. So I think we'll stop there for some time, and then I'll put some new information on the board, and then we'll proceed from there. Okay.